Hello everyone, it's a pleasure meeting you all in my mathematics class. Today let me solve this homogeneous partial differential equations problem with constant coefficients. Here this is the problem. I have named it as 1, and here it is your d is nothing but dou z by dou x. D dash is dou z by dou y, and so this is the problem given. Now we have to solve this partial differential equation for z, and I have written here that the solution to a partial differential equation follows the same methodology of doing a ordinary differential equation with some difference here and there. And the solution is given as we give in ordinary differential equations. This z is equal to complementary function plus particular integral. In ordinary differential equations, we give it as y is equal to complementary function plus particular integral, because y is a dependent function and it depends on x, and x is an independent variable, and we solve and give the solution like this. In the same way we do here also. About the way how to do that, I have given a very good explanation in my previous videos. You may just watch and get a knowledge on that. Okay. Now, so this is what is. Now, as I told you, we have to follow the same method as we do in ordinary differential equations. So you see that I am trying to find out what is my auxiliary equation. See, auxiliary equation means here take d is equal to m and d dash is equal to what? Take d is equal to m and d dash is equal to 1. Take d is equal to m and d dash is equal to 1. In this, that is, take this d squared minus 6dt dash plus 5d dash squared, obviously is equal to 0. That's a homogeneous equation. And the auxiliary equation is given by m squared minus 6m plus 5 is equal to 0. Taking m is equal to d is equal to m, say d is equal to m and d dash is equal to 1. And that when you factorize this, you get m minus 1 and 2. Because you factorize this, you will get this m squared minus 6m plus 5. This implies that the value of m is equal to 1 and m is equal to 5. And therefore, the complementary function is now given by phi 1 of y plus 5x plus phi 2 of y plus x, because 5 and 1 are the roots of the equation. So our first part of the problem is over, that is finding the complementary function is over. Let us come to finding the particular integral. Now the particular integral is given by, what is our particular integral? See, the particular integral will be like this, 1 by c. Particular integral is equal to your e to the power of x sine hy plus xy divided by d squared minus 6dt dash plus 5d. So this is the particular integral. But this particular integral, you see that I split it into two particular integrals, namely pi, see I have written here, pi1 is equal to e to the power of x sine hy divided by this. But the equivalent of sine hy is equal to e to the power of y minus e to the power of minus y divided by 2, and which in turn can be written as e to the power of x plus y minus e to the power of x minus y divided by 2. Take this e to the power of x inside. You will get it as e to the power of x plus y minus e to the power of x minus y divided by 2. Now you have to go for the integration of this with respect to the denominator at the bottom. Now I will call this, see, I will call the first in this itself I take pi1 dash. What is pi1 dash? Particular integral 1, in which I can take it as pi1 dash, and this pi1 dash is equal to 1. See, I factorize. See, what is the factorization of this? D minus c, d minus phi d dash into d minus d dash. You multiply this, you will get this. Okay. So I have factorized and kept. And this must be operated on. First, I will take this half of e to the power of x plus 1. So what is that you will get here? So when you do that, now you can substitute. See, you can substitute what is, so when you do the integration on e to the power of x plus y, here the coefficient of x is 1, the coefficient of x is 1 and coefficient of y is also 1. So wherever d comes, you can put it as what? Yeah, the coefficient, see, e to the power of, it is like this, e to the power of ax plus by. And when you go for this, when you go for the integration, you can replace this d by a and d dash by b. D by a and d dash by b. And if it is d square, you can replace it by a square. So you see that I will replace this, but provided you can replace or you can substitute d is equal to a and d dash is equal to b, and or d squared is equal to a squared, d dash squared is equal to b squared, you can substitute, provided the denominator, that is the f of dt dash, does not become 0. This is nothing but your f of dt dash. That means this is nothing but an expression consisting of d and d dash. So this f of dt dash should not become 0 when you put d is equal to a and d dash is equal to b. That is your, this should not become 0. See, f of dd dash must not be equal to 0. If it is equal to 0, we will do in a different. We have to apply a different method to get the answer because it cannot become 0. Okay. Now, so pi dash is equal to d minus this one. Now you see that a is equal to 1. See here, a is equal to 1. B is equal to 1. A is equal to 1 and B is equal to 1. When you substitute here, it is 1 and it is minus 5, minus 4. But when you substitute here 1 and d dash 1, it becomes 0. So we cannot do that. But wherever the, that is the, in the factorization, wherever if you apply the values of a and b, if it doesn't become 0, you carry out. And where it becomes 0, you cannot do that. You go for some other method. Okay. Now, you see that when you substitute here, it becomes minus 4. For this, it is not become 0. So, don't do that. So, keep it as minus 1 by 4, 1 by 2. And when you come to this, if you want to, that is, you differentiate the denominator with respect to d and write it as minus, see here it is, when you do this, it is minus x into, when you differentiate this, what happens is differentiation of d with respect to d is 1. And this differentiation of d dash with respect to d is 0. So you get only differentiation of d is 1. And when you do that, it is minus, you have to write it as minus x into 1 by d into e to the power of x plus 1. Okay. That means, now the answer for this is, so when you do this, since this becomes 0, you cannot directly substitute the values, it will become 0. So what you have to do is differentiate the denominator with respect to x and with respect to d, differentiate with respect to d. With respect to d, this is 1, d dash is 0. So when you do that and write it as x into e to the power of x plus y divided by the denominator. What is that? Minus 4 into 2, it is 8. So the answer for this is minus x by 8 into e to the power of x plus y. Here you must note that you can substitute the values only when it does not become 0. When it becomes 0, the method is that you have to put x. Suppose if the second time also it becomes 0, means it will become minus x squared into 1 by something like that. So it goes on. This is the method of doing it. So better know it. Okay. And if you are so particular, write to me. I will just or I will do a problem explaining fully how this comes, that I can do. But coming to this problem as such, I am telling you that this is the way it should be done. That means it is, you put it as my x into e to the power of x plus y divided by differentiate, because if you differentiate, that is 1, nothing. D dash means 0. So that's all. So this is my answer for this particular integral. 1 dash is minus x by 8 into e to the power of x plus y. Let me come to pi1 double dash. What is my pi1 double dash? It is nothing but what? It is minus e to the power of x minus y divided by 2 divided by the same denominator. So you see that here it is very simple, because you see that when you put a, here a is equal to 1, see? Here a is equal to 1, b is equal to minus 1. Here it does not become 0. See? Here if you put x is equal to 1, this will be your 1 plus 5 will be 6. And this 1 plus 1 will be 2. Put a is equal, a is 1 and b is minus the d dash. D is 1 and d dash is minus 1. See? Here it is. See? A is 1 and b is minus 1. So substitute the values. In the place of d you put 1. In the place of d dash you put minus 1. So this will be 6 and this will be 2, and therefore 6 into 2 minus 1 by 24 into e to the power of xy. So you see that I am able to get this one and this one. And here this denominator does not become 0. So you can carry out. But here it so happened that it is becoming 0. I have to apply the other method to get the answer. So that is how I am getting this. The second one is also got like this. Now let me come to the pi2. What is my pi2? pi2 is nothing but 1 by d square minus 6d dash plus 5d d dash square into xy. And what you have to do here is that you have to go for this is nothing but it's a polynomial. It's a polynomial. So you see it is an expression of second degree or whatever it is involving x and y. Now we have to, how the integration done here is that take this d squared outside, take this, the method of doing it. So take this d squared outside, so we will be left with 1 minus 6d dash divided by d plus 5d dash squared by d squared. And when it comes to the top, therefore 1 by d squared into, when it comes to the numerator, it is nothing but 1 minus 6d dash plus 5d dash squared by d squared whole to the power of minus 1 into xy. Now you have to carry out the integration with respect to this on xy. That is the meaning of it. Okay. Now, so when you do this, now when you go for this, this is nothing but your 1, see it is like this, 1 minus x to the power of minus 1, 1 plus x square plus x to the power of, see like that, this goes on. So the expansion of this 1 minus x to the power of minus 1 is 1 plus x square. So I use that idea, but what happens is that I don't write this. See, I keep that like this, and I don't write this. That is, this is nothing but, I stop with this. So this is nothing but 1 by d square into 1 minus d6 dash by d into x1, 1 plus. See, why I write here is that here it is 1 plus 6d dash. Now, I don't write the other terms for the simple reason that if I write this, it will become d dash squared and higher powers of d dash. But here you must know that this xy comes, and when you, the d dash of xy means you have to differentiate xy with respect to y. So when you do the differentiation with respect to y, x will be treated as a constant, and the first differentiation will be with y with respect to itself is 1. The second derivative with respect to y will be 0, because it becomes a constant, there is no y term, or 1. So the differentiation of the 1 is 0 with respect to y. So that is why I am not writing the other terms here. So it is 1 by d square into 1 plus 6d dash divided by d into y. So in this place 1 by d square into 1 minus 6d dash 1 plus, I have written here, see, 1 plus. So I take this inside. Take this inside. 1 by d square into xy. See, 1 by d, I have written here, 1 by d square into 1 plus 6d dash divided by d into xy. Because in this place I can write this, giving up all the higher powers, because higher powers will make y, differentiation of y with respect to y0. So this is what I get. Now take this xy inside. So 1 by d square into xy plus 6 into d dash. That means differentiate xy with respect to y. So what happens is, with respect to y means it is 1. So you will be left only with x. Now, what is the meaning of this? 6 by d into x. 1 by, see, d of x means differentiation of x with respect to x. If I write 1 by d means it is nothing but the integration of x with respect to x. Okay. So, it is 1 by d of x means now you have to integrate x. Therefore, when you go for this integration, so that is why I have written here, see, 1 by d square into xy plus 6 by d. d of x means integration of x here. So 6 of this. Now what is this? The integration of x to the power of n is x to the power of n plus 1 divided by n plus 1. So using that idea, 1 by d square into xy plus 6 into x squared by 2, that is why I get it as 3x squared. Now you see that what is the meaning of this? 1 by d square, again you have to integrate this twice. The 1 by d square means integrate this factor twice with respect to x. So if you, I will go for the first integration. That means 1 by d of 1, this one. So the first integration will be integral of xy with respect to x, integral of 3x squared with respect to x. That is what I have written here. 1 by d into integral of xy with respect to x plus 3x squared with respect to x. So when you integrate this is x squared by 2. See, 1 by d into within brackets x squared by 2 of y plus the integration of this will be x cubed by 3. 3 and 3 will go off, giving you x cubed. So in this place, what is it you will write? 1 by d into x squared by 2y plus x cubed. But 1 by d, again it means that you have to integrate this with respect to x. So nothing but integral of x squared y by 2 plus integral of x cubed. So you have to integrate with respect to x. When you do the integration here, it is nothing but y is treated as a constant. So y into integral of this is x cubed by 6. The integration of this is x to the power of 4 by 4. Now, so what is that? We have got this pi2 is this one. Pi2 is this one. So I have got this, see, this one. So I have got all the three. So for this, z is equal to complementary function plus particular integral. That means here z means this is your complementary function. Particular integral means I have got 2 here. Pi1 means I have got Pi1 dash, Pi2 dash. That is why I am writing it as what? 1. See, 1 plus this is also a particular integral. This is also a particular integral here. And this is another particular integral. Therefore, 1 plus 2 plus 3 plus 4. That is, z is equal to phi 1 of what is our complementary function? Phi 1 of y plus 5x plus phi 2 of y plus x minus x by 8 into e to the power of x plus y minus 1 by 24 e to the power of x minus y, and the last one is plus x cubed by or y x cubed divided by 6 plus x to the power of 4 by 4. So this is my final answer for the